Chapter 33, Fundamentals of Hydraulic and Air over Hydraulic Braking Systems, Day 2, Video 2, Hydraulic Principles. So here we've got kind of a basic system set up here. Looking on the left side here, this would be our brake master cylinder. Okay, this is where we're going to create the pressure. And out here would be the wheel cylinder where we're going to use that pressure to create the work that we need. We've got a surface area on this piston of 1 square inch, and through the brake pedal and the linkage I am putting a direct force of 5 pounds of force against this piston. So I'm pushing with my foot on the brake pedal with 5 pounds of force. This piston will start to move. It is a closed circuit or closed system here, so that hydraulic fluid is trapped in here. So what I end up doing is pressurizing that brake fluid. 5 pounds of force here, and a 1 square inch, so I've created 5 pounds of force. Right now we're going to transfer that pressurized fluid, or the pressure from the fluid, down the brake line. We've got showing here just a very short line, but it could be from the front of the truck, and the work here, our wheel cylinder, could be at the very back of the truck. So 10, 15, 20 feet away, we're creating the pressure here, and now we're going to use that at the back of the truck up to 20 feet away. So that pressure transfers through the brake line and now comes into the wheel cylinder. 5 pounds of pressure working on this piston, which is also 1 square inch. So I'm going to have 5 pounds of force pushing piston number 2 over to, attach to the brake shoes, or the brake pads, what have you, to create the braking force. So we are creating the pressure in our master cylinder, transferring that pressure through the brake lines, and then now that pressure is acting on the piston out here in the wheel cylinder, doing the work here at this end. And doing so, when I push down on the piston, I've moved this piston 1 inch, and it's displaced a specific amount of fluid, right? And it just so happens that this wheel cylinder is of the same diameter, so this piston will move 1 inch. I've displaced this much fluid. That fluid will come through, and it has to work in this confined space right here. So we've created the pressure, transferred that pressure, created the work out there at the brakes. Very similar situation here. Again, a master cylinder, connecting line, and then our wheel cylinder here. So again, I'm pushing with 5 pounds of force on this 1 square inch piston. It's displaced it's moved 1 inch, right? So I've pressurized this brake fluid, 5 pounds of pressure, and that pressure is transferred through the line to the back of the truck, 15, 20 feet away. And now that 5 pounds of pressure is acting on this wheel cylinder. In this case, we've got twice as big of a piston in the wheel cylinder. So that 5 pounds working on 2 square inches of surface area, I get 10 pounds of force out here at the wheel cylinder. So the mechanical advantage, or the hydraulic advantage we get of that, is creating pressure here, and then now we've increased the size of the piston. We get twice as much force out here at the wheel cylinder. So again, I've moved this piston 1 inch. It's displaced a certain amount of volume of the brake fluid as it's pressurizing it into the wheel cylinder, which is twice as big. So we've only displaced a certain amount of fluid here. It's only going to move this piston half that distance, or half an inch, because there's a larger volume of fluid in this. So we'd get twice the pressure, but half the distance. So we would just take that into account when we are designing this brake system.